Hi, hello viewers. All right, let's quickly look at this question here. Question is coming from WAEC question 2023, the theory question number 2. Now, what does the question read? The question says, an experiment of 20 cm cube of a solution containing 4 gram per dm cube of sodium hydroxide was neutralized by 8 cm cube of sulfuric acid. I asked two questions here. First of all, we are asked to write the balanced equation of that reaction. And second of all, we are asked to calculate the concentration of that acid. As easy as that. Now, let's dive into that question. First of all, reaction between sodium hydroxide and sulfuric acid. So the reaction is sodium hydroxide plus sulfuric acid, that's H2SO4, produces. Now we know that when an acid reacts with an alkaline, we produce salt and water. So first of all, water will be produced, H2O. Now what salt will be formed from here? Remember the definition of a salt. A salt is formed when the hydrogen ion of an acid is replaced by a metal. So we replace this hydrogen with sodium, and that will be Na2SO4. And we notice that we have to balance the equation here. So the equation is now balanced. So we have gotten the first part of the equation by balancing the reaction. Now the second part, we are asked to calculate for the concentration of the acid in mole per dm cube. Very easy. How do we calculate for concentration of the acid in mole per dm cube? We have to use this formula, concentration of acid, ratio formula, times volume of acid all over concentration of base times volume of base equal to number of acid all over number of base. Now, what does all this parameter mean? The Ca simply means concentration of acid in mole per dm cube, which we are asked to find. Ca, we are asked to find the volume of the acid that was neutralized by the base, and it was given to us as 8 cm cube. 8 cm cube. The volume of the base was given to us as 20 cm cube, right? 20 cm cube. Now, what are the number of acid in the balanced equation? The acid is 1. The number of base in the balanced equation is 2. Now, we have a little problem here. The concentration of the base was not given to us. So we cannot use this formula to calculate for two unknowns. Very easy. Now, we are not given the molar concentration of the base, but we are given something about the base. We are told that the base, sodium hydroxide, was prepared by dissolving 4 gram per dm cube. This is the mass concentration. Now we can use this mass concentration to calculate for the molar concentration, and then use that to calculate for the molar concentration of the acid. Very easy. Now, what is the concentration in mole per dm cube, which is the Cb of the base of potassium hydroxide? Very easy. Using the mass concentration, it is molar concentration is equal to mass concentration all over the molar mass. Now, what's the molar mass of sodium hydroxide? Sodium, we know sodium is 23, plus oxygen is 16, plus hydrogen is 1. Let's add up that 23 plus 1 plus 16. That gives us 40. So the molar mass of potassium hydroxide is 40. Hope you know how I got the molar mass. Molar mass is just the sum of all the elements found in the base. Sorry, sodium hydroxide. Sodium hydroxide. Now, this is the molar mass. Now, what is the mass concentration? It's 4. Remember that we want to calculate for the what? The molar concentration, but we are given the mass concentration, and we know that the formula for molar concentration is mass concentration divided by the molar mass. So 4 divide 40, that should give us 0.1, right? That should give us 0.1. So the molar concentration of the base is 0.1 mole per dm cube of sodium hydroxide. So we've gotten our Cb to be 0.1 mole per dm cube. Now let's make our Ca the subject of the formula from this equation we have here. If we make our Ca the subject of the formula will be Cb, concentration of the base, which is 0.1, times volume of the base, which is 20, times number of acid, which is 1 in the balance equation, divided by volume of base, given to us as volume of acid rather, volume of acid times number of base. Now let's plug in all our parameters here. This is number of acid, number of base rather, number of acid, sorry. Now let's plug in concentration of the base in mole per dm cube. It is 0.1. Volume of the base is 20. Number of acid in the balance equation is 1 all over volume of acid given to us as 8 times number of base in the balance equation, that's 2. So if we simplify that, let's simplify that. 0.1 times 20, that gives us 2, and 8 times 2 gives us 16. So 2 divide 16, that gives us 0.125 mole per dm cube of the acid H2SO4. If you enjoy watching this video, make sure you subscribe to this page, share to your friends, and have a nice day. See you in the next one.